And OCaml, for you who don't know, I'm sure lots of you know what OCaml is. This is a functional programming audience. But if you haven't come across OCaml before, it is a pragmatic systems language with over 30 years of research and development. And it's what I call an 80% safe language. And the 80% here would be comparing to the 100% of what Haskell is. So like in Haskell, even like side effects are type checked. You have to go through a lot of ceremony to get things done if you need to interface with the outside world. But OCaml has some escape hatches that let you do some side effects. They're still typed, but there's not a lot of ceremony involved. It's also a safe language, as in tries to and actually achieves generating correct programs. It is mostly functional, but you can actually write imperative code or object-oriented code in OCaml. So it has all these escape hatches, and it's actually multi-purpose and multi-target. It's also really fast, and it has a very powerful module system. And you can think of OCaml modules as like mini files, where you can have like files, modules inside modules, but then a .ml file or .re file in the case of Reason is also a module. So those are nested, and they allow you to do very cool things. But that's a topic for a whole other talk. So you're welcome to come talk to me after the talk, and we can digress about modules all you want. This talk is specifically going to be about the multi-target part of OCaml. And as I've mentioned, it's multi-target, but I didn't tell you what the targets are. And so here we can see that OCaml can compile to JavaScript, and there are a couple compilers. There's this thing in OCaml where there's 2 of everything, so there's 2 compilers for compiling OCaml to JavaScript. It can also compile to portable OCaml bytecode and native assembly instructions. And recently, there's been a lot of work in making OCaml compile to WebAssembly too, and that's upcoming work. If you're following the slides, these are all links that you can follow to the tools. Again, this talk is going to be focused on one particular aspect of the multi-target and multi-purpose part of paradigms of OCaml, and specifically I'm going to speak about compiling to native assembly instructions, which is really fast native code. But before we get into that, so this talk is about native compilation, compile to bare metal, but like, what even is bare metal, right? In one way or the other, today most of our code runs in a VM, and so, or at least from my perspective, I've been running code in a VM for such a long time that when I started doing OCaml and compile to native assembly instructions, I was like, whoa, computers can be that fast? And I was like, surprised again. But it's a trade-off. People run codes in VMs, and because it's choosing between something that has lots of stuff baked in, also including lots of standard libraries. And the other side of the spectrum is running code outside of VM normally, where you have to do manual memory management yourself and all that. Go and Rust are probably exceptions here. So is OCaml and Haskell, which make other trade-offs. But anyway, again, there's enough content here for another talk. So what I'm going to be focusing on is talking about my workflow for doing a native OCaml, and the goal with the next part of the talk is to show you that while the native package management and build tooling for OCaml has historically been a little outdated and maybe even antiquated, it has now come forward. And you can actually have a really cool workflow thanks to some of the tools that I'm going to be talking about. But first, we're going to distinguish between package management and build tooling. And in some languages, they're often conflated, and like the same tool can do both things. But we're going to make the distinction of like what is the tool that can fetch our packages, resolve our dependencies, and what is the tool that can actually build our code, given that everything else is in the right place. And so regarding package managers, there was nothing in OCaml for a while, and so people would just vendor dependencies, resolve transitive dependencies themselves. But in 2013, the OCaml package manager, or OPAM for short, was started, and it's still in use today. And it's a tool that has like a central repo, or actually several repos if you want to have one inside of your organization. And they can distribute can distribute packages. And Easy is this tool that was started in late 2016, which kind of uses both the NPM package ecosystem and the OPAM package ecosystem, and uses both of them to get packages for your code. And it has other advantages that I'm going to talk about in a little bit. So OPAM, as I said, it also packages the OCaml compiler versions and the compiler libraries. It has what I call mutable global switches, which for me at the time made it very hard to set up, and especially set up things in a reproducible way. And it creates one global switch in your computer with all the OCaml packages that you want to install, right? And then say you want to upgrade a version of one dependency that you have that conflicts with another dependency that you have installed, and then you either have to uninstall one of them or not upgrade. So it was a little bit hard to set up when I tried it like a year and a half ago or something like that. But it's recently come a little bit further, and it has, in version 2, it has local per project switches, which still a local switch. It's kind of a local compiler and package ecosystem within your project. But it's also kind of mutable in a sense, and it can have some reproducibility issues. And then there's Easy, which is what I'm going to be focusing today mostly on. And it's what I've been using for the past, I don't know, couple months or more. And Easy has a package.json driven workflow. So if you're familiar with JavaScript or the NPM ecosystem, it kind of has the same workflow. You can install it with a familiar npm install command. And then what it has is it has what they're called sandboxed and reproducible builds. And what this means is that whenever you invoke the Easy command, it kind of overrides most of the environment variables in your path, such that they now point to a local sandbox that refers to your project. And sandbox can be kind of an overloaded term, and where we're using it here to mean that there are some restrictions in that your environment is restricted, and also that some installation steps, writing to a randomly part of your, in your random path in your disk is forbidden. And then this all sounds really nice, but then if you actually have all this, if you have multiple projects and then you have multiple sandboxes, it can take a long time to build your code if you don't have what Easy chose to do, which is a globally shared build cache. So across all projects, there's a global build cache, which caches the builds of all packages, all versions that you have installed before across all your projects. And so I'm going to do a little demo later where I've already installed that demo, so it will be almost instant to set up a project because I've built all the dependencies that it has before in another project. Okay, so what I meant by running in a sandbox environment is that, so if you run Easy install, it will read your package.json, it will install all dependencies, the OCaml compiler that you chose, and all that. But you can also start Vim, for example, here at the bottom. You can do Easy Vim, and then Vim will get the environment and all the context that you have that you defined in your package. So so you have editor tooling that is dependent on different versions of compiler. if you run easy Vim, Vim will get all the environment variables that are specific to the local easy sandbox that you set up. And so this can be really helpful. Right. And then OCaml, easy is not specific to OCaml or Reason. It's actually a very young tool, and it's where the focus has been. But in fact, you can package any executable or library in any language for easy consumption. We do this for package config, OpenSSL, libev, and like a bunch of C packages that just makes it easy to get all those packages available in your local sandbox. So like if you're running, say, NixOS and some, that installs your packages to like a Nix store behind a hash, it can be hard for a global tool to know where those packages are. So like you can have all these external dependencies packaged for easy and consume them in your project, and they'll be local to your project sandbox. And I think we'll be doing much more of easy packaging of certain tools in the future. But anyway, I digress. This is also a topic for a whole other talk. I'm getting too excited about this. All right. So what is in the build tooling space in OCaml? It has historically been very crowded and mostly not beginner friendly. It all started with giant makefiles and this tool called OMake, which kind of did makefiles but specific to OCaml, and then OCaml build with generated thousands of lines of build tooling. So it wasn't historically it wasn't very beginner friendly or even friendly for people that were already experienced with the language. Which is why recently there was this effort to make a tool called Dune. It's actually started as JBuilder, and so it originated inside a company called Jane Street, which, if you've heard of, they claim to be the largest industrial user of OCaml, and this build tool was started internal to the company in order to solve their problems with building their OCaml code, but has, in the meantime, it has been open sourced and adapted for the OCaml community, and I think it's a modern tool that knows about lots of stuff in the OCaml toolchain and supports really fast, separate and incremental compilation. And so we're going to see an example of a workflow where we're going to use Easy as our package manager, and then we're going to use Dune as our build system. And I think they fit really well together, and so we're going to see an example of that shortly. Just before we get the demo, and this is kind of not related to what I'm talking about, but like recently, AWS, they added support for what are custom OCaml, custom runtimes for AWS Lambda. And sorry, show of hands, who knows what AWS Lambda is? Right. So for those who don't know what AWS Lambda is, they can be thought of as a function as a service offering, which lets you basically upload a function that will be run in the cloud and automatically scalable out of the box. And it's very popular in the Node.js space, and before this custom runtime offering, it was they only supported, I think, like Node.js, Golang, and some other languages. But now everyone can just do their own runtime, and we're going to see a little example of that if time permits. Anyway. We're going to see a little demo now. And I need to stop mirroring screens. Or actually the opposite. OK. How's font size for everybody? Can you read this? In the back. Awesome. OK. So we're going to make a directory called demo, which exists. OK, never mind. I don't know why. We're going to remove that. So we're going to make a directory called demo. And we're going to do like npm init, because this just is going to create a package JSON for us. I don't care of anything that this creates. It's fine. And so we're going into our package JSON, and it's just useful to have it here, because I don't have to create it myself. And we're going to say, I want some dependencies to be installed. And what I want is, I want OCaml. Give me the latest version that you have. I want Dune, which we're going to use to build our code. Also, you can give me the latest version. And Reason, the language, is actually distributed through OPAM. So we're going to also install Reason, and just figure out which versions you're going to install for me. Like I don't want to care about like specifying versions. Just give me all the latest ones. And so we're going to go here, and we're going to say easy, right? And then easy is just going to read my package JSON, resolve all the dependencies, and then install all the dependencies and have my local sandbox ready for development. And the reason why this was so fast is because I've done this before, and like all the packages that I require are already installed locally in my global shared cache. OK. So now we're going to create a directory called source, and we're going to create a file called Dune, which we'll use to build our executable. And we're also going to create a demo.re file. And so we need to tell Dune what our project is. And in this case, I'm just going to say that I want an executable. I can't type. Executable. And the name of this executable is going to be demo. And so this actually matches the file name that I created, which is demo.re. And so I'm going to say, go to demo.re, and I say, let something. I don't care what it is. I don't care about the result. Just print. God. Print hello fby. OK. And then right now, we can do like easy build, and then easy build actually gets us into the build context of easy, which is a very even more so I mentioned about easy Vim, right? Where like I could start Vim with in the easy sandbox. And then easy also has like a X and a B, or build context, which restricts the sandbox even further. So I actually want to do like, I want to build my project inside this very restrictive sandbox where only my dependencies are and nothing else. And so I want to build that, and I think it built already, and then I can say, well, actually, I could, let's try to run this. Easy, easy b exec, and then I want to execute the demo that I created. And Dune has this notion of an implicit dot executable target, because I declared that I was going to build an executable. All right, so yeah, hey, we built something, it executed. But this is just printing something to the console. This is not very useful or even fun to see. So I've prepared another demo, which is why I mentioned AWS Lambda to you all. And so this demo, we're going to go through the code a little bit. And this is just a Lambda. And what this does is basically a Lambda is a handler from a request and a context to a response. And we're going to use this tool called Zeit. And they have this now.sh service, which is where my slides were hosted, actually. And what we're going to do is we're going to build an OCaml Lambda function. We're going to bundle it with the OCaml custom runtime for AWS Lambda. We're going to deploy it to the now service. It's going to take care of setting up a remote HTTP endpoint for us. And then on every invocation, it's going to give us a random picture of a dog. OK, let's do this. So let's go through the code a little bit before that. And so my handler is just a function from a request and a context to a response. And what I'm saying is get a dog picture, and then this is just an infix operator to lift the result. It's like the Haskell's I think the do syntax, but like with with an infix operator. And so we get the dog picture, and then we send a response. Getting a dog picture looks like going to this dog CEO API, which I found out recently, and I love it actually. You should check it out. And then we're going to send a request to that URI, get a JSON response, extract an image URL from that response, and then, oh, wow, wait, there you go. And then grab that image URL, put it in an HTML string, and then send a response. And so sending a response is just basically returning a record of a status code. This is an HTTP status code. Some headers with the content type, and then the body. And the body is just the HTML the HTML that has our image URL. OK. So we've seen that. And then I'm actually going to go in this project. OK, I've built the project before. I can do clean, and I can do Dune build. I think this is source Lambda executable. So it builds my project. It doesn't actually run locally, and I can try to do that, but like it's meant to run in a AWS Lambda context. So it actually just doesn't do anything useful here because it expects some context variables to be set. And so what we're going to do is, and I have a little build script here because there's some setup entailed. Because in order for our code to run in AWS Lambda, it needs to be compiled into a statically linked executable. And so I just have a Docker file with Linux where I build my code, and then I extract that statically linked executable from the Docker container, and it should be here, and it should be called Bootstrap. And we can double check that Bootstrap is actually a ELF executable for Linux. So I have prepared a now.json configuration file, which will deploy a Lambda called funcbydogs. And it's going to use a custom runtime to deploy our Bootstrap Lambda. I think this should, yeah, exactly, because it's going to take our Bootstrap file and deploy it with a custom runtime builder. We don't need to get into that right now. So I hope the Wi-Fi is good here. So we're just going to do this, and we're uploading our statically linked executable, which is about 10 megs, and then this is going to do all the building and ship that to AWS Lambda. It's going to produce, I think, a little smaller exa Lambda. And this is important because these things need to be a little small for the startup time to be fast enough. So now we're just waiting on the Wi-Fi to upload. Yeah. What? Yeah, let me show you something. In this case, we're using this service. Okay, those are it's called Zeit. I'm not sure if you've heard of them. They recently launched a service. Well, this standard disclaimer. I'm not affiliated with them in any way. I just really love their service, so it's what I'm using. And so they launched this Lambda offering, which lets you just push code to AWS Lambda, and they will set up an HTTP endpoint for you and call your Lambda automatically. And so I think this is finished uploading. And now what this is what I mentioned is we got a URL for like an immutable URL to our Lambda, the Lambda that we're deploying. then this is building, it's deploying, and now it says, OK, this is ready. It's in the Brussels region, because we're closer to that. And then it produced an executable of 3 megs. And so I'm just going to copy this URL and try to see if our code works. And look at that. How cute is that dog? Oh, my God. And then, OK, so if we refresh, we get a random dog picture every time. I can't handle this. This is too cute. All right. Let's try to go back to our slides. OK, so we saw that. And just to recap, we went from 0 to a hello world thing where we printed out to the standard output, just hello. And then in just a few steps, we had, we had a native Lambda deployment deployed to the cloud, which is infinitely scalable out of the box and has minimal overhead to start up. And so I think this is really cool. Anyway, this is all I had to show you. There are some links here if you want to get started with Reason. You can join our Discord. And this is the custom runtime that I built for OCaml. I can take any questions now if you like. I think there's one over there.
Hi, thank you for the talk. So the question basically is so the ReasonML native feels like full circle, you know, to the OCaml where all this has been started, right?
So the only thing that Reason is just the syntax on top of OCaml. It uses all the underlying toolchain, which is why we get such powerful and
okay.
like
I see. So
cool ecosystem.
Is there any overhead in there?
For Reason?
No, I'm using ReasonML native to basically build an executable that you could build with OCaml in first place. Right.
So what ReasonML is technically is a front end to the OCaml compiler.
Right.
So the generated code is exactly the same. So there's no overhead.
Oh, okay.
Like absolutely no overhead in writing your code in OCaml or writing it in Reason.
Yeah, right.
It's just, you know, pick which syntax you prefer, use it, and then the compiled binary will be the exact same.
Oh, that's fine. For me. Cool. Thanks.
Anyone else?
Well, thank you for the talk, but could you make it clear, please, for me personally, what exactly can Easy do which OPAM and Dune cannot?
So Easy is not a replacement for Dune, so like it's still using it to build code. It's an alternative to OPAM in a way that it's a fairly different workflow to achieve the same purpose. So what it gives you instead of a global mutable switch is like a per project sandbox that you can add specific, you can pin specific resolutions of transitive dependencies in order to achieve reproducible builds. And you can do this in a declarative way using the config format. And I could be missing something, but like the last time I tried OPAM, it lets you do the same thing, but like you have to memorize like it's very trial and error, and it's like which dependencies do I need to pin now, like, and why don't these versions work very well together? And you sort of lose a lot of time trying to figure out like what the exact pins and versions you need to have in order for your build to run. And then the next day, if something upgrades, like and you try to set up the same project in a different box, I have found that it's not as easily reproducible as it is with Easy, for example. So it's just my preferred workflow right now.
Thanks.
Any more questions? Right, I guess that's it.
Right.
Thank you, Antonio.
Thanks.
We have a lunch break right now. It will last about an hour. We started 2 p.m. 10 minutes. So lunch is served at the entrance by the wardrobe. Please enjoy your meals.